Okay, and we're back. So, this is the third and final part. I hope you found this series useful to you. Uh, so far we did digital in and out, not in and out, just digital out, and PWM control. Now we are going to do analog read, which is basically we are gonna try to read analog voltage from the Arduino and then display it inside LabVIEW. Now, the source of my analog signal will be from this point here. Exactly, what is this? This is an LDR, light dependent resistor. What does that mean? Simple. It's a resistor that changes its resistance value according to the how much light intensity there on the sensor. Now, there are two types of LDRs. You have positive coefficient and negative coefficient. What do I mean by that? Positive coefficient means when there is more light on the sensor, its resistance increases. And when there is less light, its resistance decreases. So negative coefficient would be just the opposite. When there's more light, resistance will increase, and when there is less light, resistance will decrease or increase. You get the idea. So that is just this sensor changes its resistance according to light, but I want to sense it in this Arduino board can only sense voltage change. So what do? Simple. I use a simple voltage divider circuit. One resistor is constant here. This one is going to be 10K, and another variable resistor which is going to be the LDR. So as the LDR value changes, the voltage will change, which will be used to show that there is change in the light intensity. Now, please keep in mind this. No two LDRs will be the same. They will not have the exact value, or the exact, maybe both of them will have the different coefficients. One of them might be positive, one of them might be negative. So LDR is usually used for detecting either 0 or 1 levels. When you have a high threshold and you didn't care about any rubbish data, you either want it to be 0 or 1. But using LDR to sense light intensity, that's not a good idea. Use something like a photodiode or anything electronic. Don't use an LDR. Just an advice. Okay, so let's start this already. So as you can see here, we have 5-volt VCC running through to this point and ground to this point, and then the output from the voltage divider goes into A0 of the Arduino. So if you want to see the LDR sensor, here is the LDR sensor. So it's just a normal resistor. As you change the value, it will change its resistance. So as light changes, it will change its value. So I'm going to place it, let's see, is this a good area for the camera? Come on, first thing, let it go inside. Actually not that great. Okay, I'll just bend it. Come on, bend. Okay, good enough. So, and this is going to be the 10K resistor connected to it to create the voltage divider circuit. Okay, almost done. We'll connect this part to ground. So to ARF ground. This is ground now, and this is going to be connected to 5-volt, and finally we have our control signal coming from the voltage divider going into A0, which is this pin right here on the Arduino. Okay, so connection wise we are done. Let's go back to LabVIEW. So maximize here. So when I left you last time, I was doing analog right PWM. So none of that is needed right now. So let's remove all these wires because they are not needed anymore. Delete this. Connect it here again, and this one again. Now right click, Arduino, low level, analog read. So place analog read here. Connect the resources up and the errors. And connect the analog pin definition outside, because if you don't do that, every time this loop will execute, and if it keeps executing every time, it will redefine the analog pin, and actually in the end it will not work properly. So it should be defined one time. So this is going to be 0, and we go to the output and say create an indicator, and here's your indicator. So it will give me a value from 0 to 4.5 volts. So right now I don't know what's this LDR's coefficient is. Is it positive? Is it negative? Don't have any idea right now. But I'll turn it on, and using Ohm's law I will find out. So if I turn it on now, let's see if it works. Okay. It should be running right now. Ooh, why is this wire loose? Okay, so the 5-volt line was loose. I just connected it back, and right now it's somewhere between 4 and 4.5, the output voltage. Remember, I said LDR is not the best sensor. It's a very noisy sensor. You will not get an exact reading of it. So I have my mobile phone. I'll turn on the flashlight and see what happens to the reading as I shine light on it. So as light increases on the sensor, the voltage drops. That means that this is a negative coefficient LDR, because if the voltage across it is dropping, that means its resistance is going down. So the farther the right is, resistance increases, voltage increases gradually from 0 to maximum 4.5. If I cover it completely in darkness, I would reach approximately 5 with my hand. If I cover it completely, I will get about 4.9. Again, if I shine my mobile phone on it, and yeah, so it's sensing the voltage coming from the sensor. Okay, so that's how you use the Arduino to measure analog voltage from your sensors, whether it's a temperature sensor, an LDR, anything that generally gives out voltage. So analog sensors in general. One note to keep in mind that, as I said before, this code is not running on the Arduino, it's just communicating with the computer. So you have to factor in the time that the Arduino takes to measure your voltage, the time that the computer takes to send and receive the data back. Because if you have an application that is time dependent, this information is very crucial to you. So once again, this is the end of the tutorial. I hope you found this tutorial useful. I thank you for your time, and have a nice day.